F block elements, guys. The F block elements, guys, are lanthanides 4F and actinides 5F, right? So 4F and 5F, guys. So F orbitals can hold a maximum of 14 electrons, right? You know this, guys. So we know that S can hold 2 electrons max, right? P can hold 6 electrons max, D can hold 10 electrons max, and F can hold 14 electrons max, right? So these lanthanides and actinides series, right, guys? So these are the F block elements, and you can remember the F block elements as well, right? If you're talking about the lanthanide series, right, this is in the F block. The lanthanum does not get filled. Its F orbital does not get filled, right? The final electron going is not into the F orbital, right? We'll talk about that later. So it's not sometime classified as a lanthanide itself, right? So lanthanide series is generally starting from 58 to 71. That is cerium to deuterium, right? And then this is actinide series from 89 to 103, guys. So this is important, right? So these are the inner transition elements, or the F block elements, right? F block elements means that the final electron is getting filled in the F block. All right. All right. So guys, the periods. Now if I talk about periods, guys, so we've talked about the groups in detail, right? S and P block, the D block, which are the transition elements, and the inner transition elements of the F block, right? We've covered the entire periodic table, right? Please remember at least till 36 you have to remember at any cost. Then there are certain elements that I've talked about. For example, molybdenum, right? Then there is palladium, right? Then of course the coinage metals in this group: copper, silver, gold, very very important. Cadmium, mercury, which come below zinc, very very important, right? Perhaps copper, nickel also you can remember, right? Apart from that, tungsten is very important, which comes below chromium and molybdenum, right? Molybdenum and tungsten are very very important, which come below chromium, right? In the same group as chromium, right? Palladium, platinum is important, which come below in the same group as nickel, right? This is very very important. The lazurite series, the first element and the last elements, perhaps if you can remember, right, the elements in this, it will be good. In the actinide series, actinium, thorium is important. Uranium comes in the actinide series. The atomic number is 92, right? This is important, right? So I'll just mark it over here, uranium, right? And then, right, lawrencium, which is the final element over here, and deuterium, which is the final element over here. These are important, guys, right? If you remember them, it's great, right? Of course, the alkali metals and the alkaline earth metals are very very important. This is not very important, guys, right? Apart from that, if we talk about the periods, right? So the periods are defined by the final shell. I mean the final shell that is getting filled, and in every shell, if there is a final shell, guys, it's the s orbital that gets filled, right? So for example, the shell that gets filled over here is 1s, right? So this is 1s1 hydrogen, right? The shell that gets filled over here after that, right, this is 1s1 and 2s 1s2 2s1, right? 1s2 2s1, this lithium, right? Similarly, sodium is 3s1, right? This potassium is 3 4s1, right? Then 5s1. So this is the first period, this is the second period, right? If we talk about these p block elements over here, right? So helium is definitely an exception, because this gives this only the second subshell, which is the 2s2, that 1s2 that gets filled, right? There is no follow-up second orbital, right? So this helium is definitely an exception over here. But if you're talking about this, right, this is 2p6, right? This is, so the p uh, it's is still the second one, right? It's still the second one. I mean, the first orbital that will definitely get filled over here. If we talk about neon also, right? Anything, right? Over here, right? In this second period, if for example I'm talking about, right, it will be 1s2, 2s2 until 2p, right? From 1 to 6, right? If you're talking about the second period, right? Similarly, if you're talking about the third period, the final, uh, I mean the final shell that will get filled is the third shell, right? So that's why this is the third period, right? The final shell that is getting filled is the third period. I mean, you won't get, for example, in the third period a 4s1 or a 4s2, right? So you might get a 3p or a you might get a 3p, right? But you won't get something like that, right? And then, for example, if you move on to 4s, then you will, what you'll get is you'll get 3d, right? You'll get 3p, right? You'll get 3d and you'll get 4p, right? If you move to the fourth shell, right? So I hope you remember what the periods are basically defined. I'll just repeat it what I said, guys. It's defined as the final orbit, right? Not the orbital, the final orbit that gets filled, right? Over here the final shell that gets filled, over here the first shell gets filled, the second shell gets filled in the second period, in the third period the second shell gets filled, right? So I hope you've understood this, guys, right? I'll move on. We've talked about this, right? Everything. Now certain things, guys. Group 1 is alkali metals, right? Group 2 is alkaline earth metals. Beryllium is not included, right? Group 15, which is the nitrogen family, is the are called the pnictogens, guys. They're called pnictogens, right? Group 16, which is the which family? The oxygen family, guys. It's called chalcogens, right? Please remember, group 16 is not carbon group, it's the oxygen group, right? So these are chalcogens. Group 17 are halogens, you've talked about that. Group 18 are noble gases, right? Group 3, guys, and the lanthanoids, right? The lanthanides, not noids, the lanthanides, guys, are the rare earth metals. So group 3 and the lanthanides are the, so basically group 3a and 3b, right? They are the rare earth metals, right? I hope you've understood this, guys, right? I'll move on. Next up, what I'll talk about is lanthanides or actinides, right? Lanthanides or lanthanoids or rare metals, right? This is not the heading, guys. This is bolded, but it's not the heading. Lanthanides or rare earths, right? These are elements from Ce2 deuterium, right? Not from lanthanum, right? I told you about this before. Then it's actinides, right? Actinides are from thorium to lawrencium, right? Even in this, actinium is not included, right? Thorium to lawrencium, guys, right? So these lanthanum and actinum, these show different properties in comparison to the other elements of the actinide and the lanthanide series, although they are named after them, right? Coinage metals, we've talked about them. They are in the same group: copper, silver, and gold. Very important, right? Noble metals, right? Very low reactivity, right? These are very important. Again, noble metals, you should remember, because they are called noble because they are very less reactive, right? So gold, silver, gold, platinum, and mercury, right? So they, because they have very low reactivity, they are used for many purposes. For example, even gold is still stored in your home, right? Because it's very less reactive, so it can survive, right? So gold has been a currency for a very long time for this very reason, right? Now it's not, right? Gold standard was removed, right? But still people store gold, right? In hopes for future, for the gold prices to rise, right? So they are traded and everything. All right. So then there are trans uranium elements, elements beyond uranium 92, right? 92 is the atomic number of uranium, I told you, right? Radioactive element uranium, right? After that, all the metals are called trans uranium metals, right? Then the bridging elements, which are the elements of the third period, guys, right? This is important. The bridging elements are the elements of the third period, right? Then there is a diagonal relationship, right? For example, between lithium and magnesium, beryllium and aluminium, and boron and silicon, right? Which, though they are placed in different groups, show some similarities in their properties. So if I just go back, right? So it says lithium and magnesium, right? For example, over here. Then beryllium and aluminium again show a diagonal relationship, right? Then boron and silicon, right? So although, guys, so this, right? Beryllium, aluminium, boron, silicon, they show a diagonal relationship. Their properties show a strong correlation, although they are not placed in the same group, right? I hope you have understood this, guys. We'll talk about the diagonal relationship and why is it shown in detail, right? Not now, right? The coming lectures we'll do that, right?